So let's talk about inequalities. And so to solve inequalities, most of the time you simplify the expression. So for linear ones, you're going to simplify the expression um, by distributing. So you simplify this as much as you can. That's all this is. Then you isolate this. So you're going to put the variable on one side and the constant term on the other. You're going to eliminate the coefficient. You're going to check. You'll check with some of that, and then you write it in a bunch of different ways. And so I'll just kind of go over this briefly. So what do we do here? So the first thing we want to do is simplify. So this is about as simple as we can get. So the next thing we're going to do is isolate. So we're going to move over 5. Okay. So we're going to move 5 minus 5 from each side. So I get minus 3x is less than or equal to 6. I'm going to divide out by the negative 3. And notice here, when you divide, I think I have it here. If each side of the inequality is multiplied by divided by a negative number, you need to switch the direction. So since I divided by negative 3, I need to swap the direction of the equality. So this is greater than, now it becomes less than 2. Okay. So the inequality be less than 2, and then here if I did it on my number line, I was going to put in a 0, we'll go 1, 2, and then
would that be less than negative 2?
I forgot my negative. This should be less than negative 2 because I'm dividing by negative 3. So I'm going to go this direction, 1, 2, and then I'm going to use the parentheses, draw an arrow. Okay. The interval notation be from minus infinity to negative 2, both in parentheses, not bracket, and the set building notation be the set of all x such that x is less than negative 2. Okay. So the one thing, if you're just solving linear equations, please pay attention. If you multiply or divide by a negative number, it's not when you add or subtract a negative number. That doesn't affect it. It's only the multiplication. Okay. All right, so let's go to the next one. Oops, I don't need that many layers. That's fine. Zoom out. All right, so for this one, we're going to do the same thing as before, and we're just going to simplify. So here, I'm going to minus 3t to both sides to get the 3t on this side. And since I'm moving all the t to this side, I want to move all the constants. So I'm going to add 7 over here and add 7 over here. So this becomes 5t. Negative 2 plus 7 will give us less than or equal to 5. And then here we'll divide by the 5. We get t is less than or equal to 1. And so here, I'll just put in a 0 somewhere. We're going to say t. And then this time I'm going to use the bracket. Okay. Bracket all the way down. And the interval is from negative infinity to 1 with the bracket. So the bracket means I'm including that number. That number is okay. The parentheses means leave that one off. And for the set builder notation, we're going to use t. I'm going to try to put little curves on my t. That way you know they're different from a plus sign. Okay. I don't think these first two are anything fun or new for you guys. For this one, the first thing we want to do is simplify. So we're going to distribute the 2 first. And so for the most part, solving linear inequalities is much like solving linear equations. It's the only real caveat here, 2 minus 6, is that when we do this, I'm actually going to move the x's over to this side, just to keep stuff positive, minus out the 6, or plus add a 6, sorry. So if I did that, I'll get 7x over minus 3. So yeah, when you're solving linear equations, linear equalities, it's very much like linear equations, except when you divide by a negative sign, you have to flip. And in that, it's more or less the same, honestly. Now, I divide by 7, so dividing by 7 doesn't flip the inequality, so I have it this way. Now, can I rewrite the equality a different way? Um, Oops. Somehow I added an equal sign that wasn't there. Yeah, so here if I write it this way, it's the same thing as writing. Now, one thing to do is say I solved this where I put the exponent on the right side. I want to put the exponent back on the left side. Then you go ahead and keep the symbol. Unless you said you learned the alligator. Just keep the alligator eating the bigger one. And so here it was eating the x. Now it's still going to be eating the x, so you just flip the way it looks. So x is less than or equal to -3/7. Okay. So here, if I put in a 0, -3/7 will be, well, let me give myself a little bit of room. So I'm going to put this as -1. And if I do the same thing over here to have the same scale, like this is 1. So 3/7 is a little less than a half. So it'll be like this. Okay. Interval notation, it'll be from -3/7 to infinity. And the set builder notation is always just, you just add in this part, the set such that, then you have your inequality. All right, so let's do something a tad more interesting now. So now we're going to solve the linear equality below, graph the solution, number line, then write out the solution. So here, when we're doing things, we have to do it to, so here I have a complex inequality, so it has more than one inequality symbols in it. So if I add, say the first thing I want to do is add 2 here. So if I add 2 here, I have to add 2 to this one and add 2 to this one. So you have to do it to each things above the relation symbols. So relation symbols are equal, less than or equal, less than, greater than, or greater than or equal. So these are all what we call relation symbols. So what's the relation of one equation or one expression to another? And so a complex one will have more than one of these. So here I have 2 of them, right? I have a less than or equals and a less than. So let's pretend I had x is equal x plus 1 equals to y plus 2 is equal to z plus 3. I mean, you could have a statement that says this. This is perfectly valid. And then if I minus this one from each, I would have x is equal to y plus 1 equal to z plus 2. Okay, and so we're going to do the same thought here, up here. Now when we add the 2, we're going to have 6 less than or equal to 3x less than or equal to, or less than, not equal to 15. Okay, then we divide out a 3, divide out a 3, divide out a 3, oops, a 3. I'm going to go ahead and give it to this, just so I have room. So here we're going to divide out a 3, divide out a 3. So here we get 2 less than or equal to x less than 5. So that's our inequality. 2 less than x, which is less than 5. And so here I'm just going to plug in a 0, just to have a 0. And then we're going to move over 1, 2. I'm going to use the circles just to, that way you have a different, that way you see both. So remember that circle, the closed circle is equivalent to the brackets, right? And the open circle is equivalent to the parentheses. Okay. So we have a closed circle, and we'll go, so that'd be 3, this would be 4, and this would be 5, and we leave an open circle. If we did this in the other notation, it'd be a bracket to open parenthesis. Okay. And the bracket will, depending on which way your line is, so you'll never have a bracket and then like this. You always put the bracket such that it's encapsulating the line. Same thing with the parentheses, you'll never see this. It's always going to be this. So I'm going to do it wrong on the other side as well. So this is correct. this is wrong, right? This is correct, this is wrong. Just so you know. I've never seen it wrong, but I give it time. All right, so interval notation be 2 to the 5. And then set builder notation is 2 less than or equal to x is less than or equal to 5. If nothing else, this section will get you used to seeing inequalities written in multiple different ways. Okay. All right, I'll take a quick drink as you guys copy that down. And then we'll get into the more complicated things here. All right. So let's talk about how to solve nonlinear inequalities. And so this is the part that would be either new or not really well known. So solving nonlinear inequalities. So you simplify as much as you can. You move everything to one side. So the variable terms and everything at this point goes to one side. You find the zeros and graph them, and then you test points in between the graph and see if they satisfy the inequality. And so let me show you how this is done. So I'm going to take this. We're going to move everything to one side. So if I move everything to one side, I'm going to move over the 5x and move over the 6, and this is going to be less than or equal to 0. So I moved everything to the left side, which is what you normally would do. Here, I can factor this. This will be x plus 2. No, this is x minus 2. X minus 3, less than or equal to 0. So here, what I'm doing here is I now can make myself a cute little number line. And on that, I'll have, and then on the number line, I'm only going to put 2 things. I'm going to put 2 and 3, my 2 zeros. So x equal to 2 is a 0, x equal to 3 is a 0. So these are 0. And since we're including, we can have 0. These will be part of our answer. Now, what are we going to do? We're going to test some points. So here, I'm going to have some test points. Well, 2 or 0 is less than 2, right? So I'm going to test 0. 2.5 is between 2 and 3, so I'm going to test 2.5. And then something above this, I don't know, I'll just choose 5, right? Now, how am I choosing these numbers? I'm just choosing something in the interval between negative infinity and 2, something in the interval between 2 and 3, and something from the interval between 3 and infinity. And I choose numbers which I think are easy to compute. And in my mind, 0 is easy to compute, 2.5 is easy to compute, and 5 is easy to compute. So what do? I just plug in 0 for x and see if it satisfies my inequality. So here I'll have 0 minus 2, 0 minus 3, which is equal to negative 2 times negative 3 is negative 6, which is that less than or equal to, or positive 6? Is that less than or equal to 0? And the answer is no. So this one doesn't work. Or another way of looking at it is here, if I have negative 2 times negative 3, that's going to give me some positive number, right? A positive number is not going to be less than or equal to 0. If I have 2.5, here we're just going to swap this out in our calculations for 2.5 and 2.5. Well, 2.5 times minus 2 is positive 0.5. This becomes negative 0.5. Positive 0.5 times negative 0.5 is negative 0. Hold on, negative 0.25. Well, that's negative, right? And that is less than 0, so that's good. Now let's plug in 5. If I plug in 5, we're just going to do this one completely in our head. And I'll show you what. So here I've shown you the long way. Let me show you what you actually do in your head. So you're going to take 5 and plug it in. So this number here is going to be 5 minus 2 is going to be positive. This number here, 5 minus 3 is going to be positive. All I really care is if this multiplication is positive or negative. That's it. That's all I care about. If it's positive, it's going to be greater than 0. If it's negative, it's going to be less than 0. And when it's equal to 0, we've already graphed these 2 points. And so what I want to do here is I'm going to create this. So in actuality, not to get you, I wanted to show you what we were doing longhand, but in shorthand, you're going to just pick points between your zeros. And all this is written up here in long language. So, solve for the zeros, graph them on a number line, test points in the interval, see if they satisfy the inequality. So here, 0, if I test 0, this multiplication becomes positive. If I test 2.5, this multiplication right here becomes negative, and if I test 5, this multiplication here becomes positive. What do I want? I want where it's negative. I want it where it's less than 0. So my inequality here would be between 2. Let me do the interval notation. So I'm going to include 2 because I'm allowed 0. Anything from here to here will be included, and I'm also going to include 3. So this is between 2 less than or equal to x less than or equal to 3. Or here, if I did this, it'd be solid dot to solid dot. Okay. All right, let me do this one more time and then see if it makes a little bit more sense. All right, so here, we're going to do this again. Simplify. This is already simplified. I've already moved it all over to one side. And I already know what the zeros are, right? The zeros are already posted for me, right? The zeros in this case are the following. So I've already done all the manipulation. So I'm at the point where I just want to state my zeros. My zeros are where x is equal to 0, 1, and 3. So I'm just going to graph those all on a number line. So 0, 1, 3. I'm going to test points. I'm going to give me some test points in the intervals. So here between negative infinity and 0, I'm just going to test negative 1. That makes something easy for me to type in. Between 0 and 1, let's just do 0.5. Between 1 and 3, I'm just going to test 2. And between 3, I'll just test 5 again. Okay. All right, so let's do this. And usually what I do is I go up to this equation, and I'll write it out here so I can, if I'm doing this in pencil. Please do not do math in pen. I see it done all the time. There's just a lot of things you just want to put down temporarily in math. Even if you are perfect in your math, there's sometimes when you're doing calculations you want to have temporary marks. Let me explain what I mean by that. So when I'm testing negative 1 here, x here would be negative. It doesn't matter what number I put in here, because whatever, if this is positive or negative, it's squared, it's always going to be positive, right? So this is negative. This is always positive, right? So this is always going to be positive. And if I plug in negative 1 here, negative 1 minus 3 is still negative. So I have a negative times a positive times a negative. So this overall would be positive. Here, let's go and switch it out from a negative 1 to 0.5. So 0.5, this becomes now positive. This is always positive. And a 0.5 minus 3 is still negative. So this ends up being negative. Here, let's test 2. 2. Well, this is still positive. This is always positive. And this still is negative. And then the last thing we want to test is 5. So let's test 5. This is positive. This is always positive. And 5 minus 3 is positive. And so we get this is positive, right? Now notice if we test any other number in these facilities, we'll get the same value. So here if I test like negative 3, right? So something in this realm, negative 3 makes this negative and makes this negative. So overall, it's still positive. And if I test 10, this would have been positive, positive, positive. So overall, it's positive. So no matter what you test, no matter what you choose for test points, it always works. Okay. So now we want to know, so what's the interval we want to work? So we want where it's negative, right? Here we're looking for, I want the negative ones, right? So the negative ones is between 0 and 1. So the interval between 0 and 1, but we do not include 1 since it's strictly less than 0. So at 1, it is 0, right? And so I can't include the 1. and then from 1 to 3. Okay. For the inequality, we have to kind of write it this way. It's a little bit cumbersome, so we're going to write from x from 0 to 1, or x less than, or 1 less than x less than 3. Okay, so here we're using the mathematical or. It could be here and here. So let's see, this one, it works fine as this or. And if we're going to graph this thing, so let's just put in a 0 here. So I go from 0 to 1. In this case, I think it'd be easier to see using the bracket. So here, bracket to bracket, or parentheses to parentheses from 1. No, I don't like that. I lied. I'm a liar. We're going to put an open circle here, an open circle here, and then add 3 open circle. All right. So that means we're going, and then I'll make this line a little bit easier for you guys to see and make these circles a little bit bigger. Okay. Set builder notation. You just write it this way. 0, x, 1, or 1. I guess I had room here, or 1, x, 3. Okay. So this may or may not be kind of new for you. But it's important to know how to handle nonlinear inequalities. And I'll get a drink. So just real quick, just to get a general sense from you guys, how many people think that I'll be doing a couple more of these problems on the discussion day and our review day? What's the symbol? Oh, so here the symbol. This is the union symbol. If I could my thing right. So here we'll have, this means union, which means include these two, and this is the intersection symbol. Intersection. So the union symbol, if I have to write one set of interval and another, we don't write. So this is basically saying in math and English, this is and. So it'd be this interval and this interval. Okay. All right. So just real quick, how many people think we're probably going to have to do some more of these in the discussion on Thursday? Anyone? Or you guys feel confident about it? Maybe like the last one. Oh, I'm feeling better. Okay, we'll see how it goes. Yes. Okay. All right, so let's do this one. So this one is as rough as it gets for you guys. So I wanted to show you something horribly, horribly rough. So in order to do this, we need to move over things to one side. So this is what I call the ugly problem. I like to always do at least one ugly problem in the notes, because you ever been in a math class where they do all the simple problems, you get to the homework and they have an ugly problem? It's like, I've never seen how to do this. I've done that. I don't teach that way, but I have been in classes where it's like, oh, we never saw anything close to this. I try not to do that very much. So let me explain how to do this. So here we move over the 1. So we're just going to follow the thing, and then we're going to try to put it together as much as we can. All right, so here for this, so it's a 1. In order to put these fractions together, I have to write this, rewrite this 1 as 1 minus x, 1 minus x. Okay. So what do I do from here to here? Did I magically embed? No, so I'm rewriting 1 as 1 times 1 minus x over 1 minus x to make them have this common denominator. But since it's multiplied by a 1 already, I just kind of left that out. And here, if I add these two together, I'll get 1 minus 1, so that's 0, x minus a negative x, so that's 2x, so I'll have 2x over 1 minus x is less than or equal to 0. For this, I would not be upset at all if you did the following. And the following is graphing it. Um, so our graphing calculator for this class is going to be Desmos. I don't know if you ever used it before. It's free. It works well. So what we're going to graph here is we're going to graph 2x divided by 1 minus x minus 1. Sorry. No, 1 minus x. I had it right. So here's our little calculator here. And so notice what we have here. So I'm looking for everything, what am I doing here? Everything greater than 0. So I want all the answers greater than 0. So from my calculator, I can see this goes from 0 basically to about 1, right? About 1, and then everything else is wrong. So it wouldn't be a bad idea to look at a graph of it to see what's going on for these more complicated ones. With that being said, how do you do this by hand? Well, you find the zeros of both top and bottom. So we're going to find the zeros of top and the bottom, or the numerator and the denominator, but I usually just say top and bottom. So for the top, the 0 is x equal to 0. When x is 0, this is 0. For the bottom, it's x equal to 1. And why we care about the bottom is because when rational functions, when my number goes between the 0 here, it'll switch the sign here. So this will go from being positive when x is less than 1 to negative when x is minus 1. So that switches its sign. And you can see that it switches its sign here because all of a sudden I'm going from I'm positive, the bottom switches its sign, and then all of a sudden it's negative. Okay. And then here is where the top part switch signs. So here the top part is negative always when this is 0, and then it switches that one. So when the numerator switches signs, it's a nice clean translation through 0. When the denominator switches signs, sometimes it's pretty abrupt like this. Okay. So let's do this. And so we're just going to draw this on a number line. All right, so here we're going to test points. And so here we're going to have 0 and 1. So the points I'm going to test is -1, 0.5, and 2. All right, so the way you test this is you just plug them in here. So if I have negative, so this would be -2 minus a -1. So -2 over 2 would just be negative. Here, if I have 0.5, this is positive, so this is positive. And then here at 2, so here 0.5 would give me 1 up top, 1 minus 0.5 would give me 0.5, so 1 divided by 0.5 is overall positive. And then here between, if we test 2, this would be positive as 4, and this being -1, so this being negative. And does that match what we have in our graph? Yeah, and it matches exactly what we have in our graph. Everything, hold on, my graph didn't quite move over. Yeah, everything between 0 to negative infinity to 0, that's all negative, right? From here, from 0 to 1, that's all positive, and between 1 to infinity, that's all negative. So that matches our graph, okay? So what do we want this time? We want the ones where they're greater than 0. And so in this case, we want this interval. So we want the interval, and we're including this, but let me be very, very careful here. Here we're going to include 0 all the way to 1. Now I'm not including 1. Can anyone tell me why I'm not going to include 1? Anyone can write that in chat. Why do I not include the 1? I mean, clearly I should, right? It's undefined, and that's very correct. So someone has the correct answer right in there. It's undefined. This function cannot take in a 1, right? It may, According to our testing, sure, right? But this cannot take in a 1 because if I plug in 1 here, I have 2 over 0, which is undefined as correctly defined in chat. And so I have to throw it away. And so when we did that domain stuff, that stuff, even though it won't, oftentimes we won't ask you directly, is this in or not in the domain? It's something you just kind of always have to have in the back burner saying, oh, that's not in the domain. And so it's just something to pay attention of. So when you see stuff like this, it's like, oh, real quick, when I get my final answer, check my domain. And that's going to be true through the entirety of your math career. And so it's just something very good to be aware of. In your engineering career, you're going to have singularities around this point, depending on what you're working on. And so singularities tend to have volatile situations when you do them numerically. So just be, it's a 0, let's make this a 1. So just be careful um, around that. Okay, so that's the end of these notes.